Well, last time we evaluated composite functions, but sometimes we don't want to evaluate it. We want to create a new function from it, so we want to leave the variables intact. And so the way this works is that we're going to look at f composed with g of x, or g composed with f of x. And if you do this once, then every time you need to reuse this composite function, you can just use your result and plug in a new number, and it's going to become a lot faster than it otherwise would be. But the way that we do this is that we remember this is f of g of x, but since this is a g of x, we don't know what it is, so we're just going to take our g of x and we're going to plug it in, x squared plus 1. Okay, now that we've done that, we just take this and replace it with wherever we see an x here. So it's equal to minus 5 times x squared plus 1. Distribute the minus 5 and we get minus 5x squared minus 5. So this is my f composed with g of x. Okay, if we come back over to here, we just work this the other way. And so we take in our value and we do g of f of x, which is g of negative 5x, which is negative 5x squared plus 1. Negative 5x squared is 25x squared plus 1. So this is our g composed with f of x. And just real quick, I want to do f composed with g of 2, just to see what will happen. That's minus 5 times 2 squared minus 5, which is minus 5 times 4 minus 5, minus 20 minus 5. And notice this comes out as the negative 25 we found before. And if we do the same thing with our g composed with f of 2, this becomes 25 times 2 squared plus 1, 25 times 4 plus 1, 100 plus 1, which is 101. Again, getting the same results we saw last time when we evaluated them on an individual number basis rather than combining them first. And you'll find that if you've done your work right, this will always work. So it's a good way to check your work if a problem has you do both an evaluation and a finding of a composite functions.